Another thing that we often use in solving equations is René Descartes' rule of signs. And I'm going to read to you a quote from him. He said, "An equation can have as many true positive roots as it contains changes of sign from plus to minus or minus to plus." All right, that's part of what we're dealing with here in his rule of signs. So let's see how we do this. I look at my f of x and I count how many times the sign changes. All right, it's positive right here and it changed to negative here. Then from negative it stayed negative until it got here, and there it changes again. So it's changed twice. That means we have 2 or 0 positive real zeros. In other words, we may have none or we may have 2. Now, if I run through an opposite of x here, f of opposite of x. Now remember, this is not the opposite of f of x, but f of the opposite of x. So I'll have to come through and plug in a minus x everywhere. Minus 8 times opposite of x plus 5. Work on that just a little bit. And I find negative x cubed is opposite of x cubed. When I square opposite of x squared, I get x squared, so this is minus 5x squared. Negative times negative is positive, so positive 8x plus 5. We're negative, and then from negative to positive we have a sign change, but then from positive to positive we don't. There is one sign change. That means there is one negative real zero of our f of x. So counting the sign changes just in the original gives us the number of possible positive real zeros. Since there were 2, I say they're either 2 or I can decrease that number by 2 and hit 0. So I have either 2 or no positive real zeros. Then looking at f of opposite of x, I get one sign change. That means there's one negative real zero. If I'd have had like a 3 there, then I would have decreased it by 2 and said we have either 3 or 1 negative real zeros. Let's do one more quick one here to illustrate this. So looking at f of x equals x squared plus 6, we have no sign changes. That tells us that we have no positive real zeros. Well, let's do f of opposite of x, and we get opposite of x squared plus 6, which is x squared plus 6. No sign changes, again from plus to plus, so that implies that there are 0 negative real zeros. That means that all of our zeros, too, we expect, are imaginary rather than real. And if you will remember, the graph of y equals x squared plus 6 turns up, and it's moved up 6 moves from the origin, so sure enough, it never comes down here and crosses the x-axis, does it? So there are no real zeros. All of those zeros are imaginary. And that concludes Descartes' rule of signs.